welcome back for the Monocotyledoneae lesson. We are going to use Eileen Chevalier's typewriter alphabet flashcards for this botany lesson. And if you look on your lesson guide for today, we are also going to use 3 really big books, but they're going to give us a great overview of the Monocotyledoneae clade. So they're all wonderful. This is the visual dictionary, the ultimate visual dictionary from DK. We're also going to use this DK Smithsonian Flora book, as well as the DK Smithsonian Natural History book. So first, we always like to write our definitions in the journal. So pull out your journal and you can record the definition as I read it for you. So Monocotyledoneae is a clade branch of the Angiospermae division that contains plants with one mono seed leaf cotyledon. So if you'll remember, the Angiospermae division, same as a phylum, and the clades are like classes. So a little bit different, but it's good to keep that in mind as we're studying these. So the Monocotyledoneae have a lot of things in common. So we're going to look at those. The first thing we're going to do in our question and investigate section is look through the DK Natural History book for an overview of how diverse the Monocotyledoneae clade is. How diverse are the sizes and shapes of the plants and their plant parts, such as the roots, the stems, the leaves, the flowers, and how diverse are their ecosystems? Like, are they just kind of all in one place, or are they all over the globe? So this book is amazing for that. They're all together. You can look through it really quickly and just kind of check out the different monocots. So that starts on page 130, and it's not super long, but we're not going to go through over all of this together, but you can thumb through it yourself. So here's the first page. So just kind of thumb through here and look at them, look at the different, I'm sure you could do a Google search as well. That'll give you a good overview of how diverse the Monocotyledoneae clade is. All right, next up, look at the trees in the Monocotyledoneae clade. What do you notice about the structure of their trunks? Examine the micrograph of the monograph stem in Flora. How might this inner structure affect the shape of the tree? So in here, we, hopefully you also had this and we're seeing them. So we saw a bunch of different palms. We saw the banana. All of these trees have like this very long trunk, and then they've got, the vegetation on the top coming out. So their leaves are up at the top, not really all the way along. So are they branching? Are they not branching? Why would that happen? So if you look at, I think I marked it in here. So this is the Flora. And this has a monocot stem and a eudicot stem. This is amazing. I love this page. We're going to see this page a lot. So up here, we have the monocot, and down here is the eudicot. So what about this structure would make all of these trees the way that they are? Like, how does the actual structure of the stem relate to what the entire tree looks like? If you see this like little kind of rainbow looking thing, like all along the outer edge of the eudicot, it has the xylem and phloem. So we'll learn more about this in the water cycle of the plant. But these are all like the veins of the plant. And so there's this very protective structure right here in this circular pattern through the trunk. So if you've ever cut into a tree, you can see the evidence of this happening over and over, right? Not into any tree, and not into a palm tree, into a eudicot tree. So like if you were to cut down an oak tree, for example, you would see all of this. And then, but if you cut down a palm tree, or like the coconut, it's also a palm coconut tree, or banana tree, you would see a totally different kind of stem. So instead of having these little pockets of vascular tissue in very ordered places, it's kind of more spread out in there. I'll try to read this to you. Sorry, I might have to back up just a little. Okay, monocot vascular bundles are scattered throughout the stem, as opposed to eudicote vascular bundles have the xylem, which is the dark green, on the inside and the phloem, blue, on the outside. So xylem and phloem vascular bundles are very ordered. These vascular bundles are all spread out. A thick cuticle surrounds the outermost cells or epidermis, helping to keep the stem watertight. So think about how that relates to the trees. Last question. Look at monocot flowers. Can you identify the petals and sepals? Read the L and 5 cards to find another way to name them. How many petals, sepals, teaples are on each flower? And can they all be divided by the same number? All right, so let's get out our flashcards. So L was our card for today, so we'll just go ahead and get that card out as well. Lily of the Valley, right here. And then 5 card has a picture of a magnolia. Now that's kind of weird because we know that today we're studying the Monocotyledoneae clade, not the magnolia diclade. So obviously some weird's going on here, but I will show you in just a moment. All right, so these are the monocots. The fun fact for monocots is that they usually have tepals instead of petals and sepals. And again, this is semantics and it's picky, so don't get confused or upset. It's okay, it's just a different term. And they're in groups of 3. Lily of the Valley has fused tepals, which is really cool. So what that just, all it means is it seems like they've like melted together. So instead of having really individual distinct petals, they've kind of mushed together. So at the bottom, you can see in this picture, this one's a little easier to see when it's large, it just has these little, it looks like a little scallop at the end. So the top of it, it's a bell shape, so it has, the top is all one piece, and then you see where they are separated at the bottom. But you can count them and you'll see that they have it in groups of 3. And here's an interesting question. How many flowers are on this stem? So, oh, there it is. There's the Lily of the Valley behind me as well. So you can see that there are 6, which I think is really interesting because you have 3, there's groups of 3 petals and sepals, and there are 6, which is also a multiple of 3 flowers on each plant, which is really interesting. Then we have the 5 card. Why are the petals of the magnolia called tepals? Sepals cover petals before the flower opens, but some flowers have sepals that look like petals. When you can't tell the difference, they are called tepals. The moth orchid is up here, right here, which is the kind of orchid that I drew. So this is like one of the most exciting things that's ever happened in my house. I've killed many orchids. And for the first time ever, I succeeded in not killing an orchid. And not only that, it is setting all these buds. So I'm incredibly excited. And this is the first time it's ever happened, so I don't really know, and I'm not an orchid expert by any means. But it has like a branch here where it looks like there are going to be more, and I've never really seen that like when you buy orchids in a store. And when I bought this orchid, it just had the one. So I don't know if like orchid experts clip these off because it gives more power to the flowers that are going to bloom, but we'll just see what happens. These seem to be doing pretty well. And I don't know how easy it's going to be for you to see these, but I just wanted to give you a chance to see if you can look at how these are connected in the bud. Sometimes it's easier in a bud to see how many When they're close up like that, it's the sepals. So these would be the outer tepals. There are. So if you can count them and see how many there are. I was looking at this the other night and I was like, oh, cool. You can see, for me, it's like, oh, okay, I see that the three of them are coming together and it's so clear. And I was like, monocot. Now, and they do look different. So you'll see that the lower one is much darker than the two that will be on the side. But when these bloom, I'll do an orchid video. Oh. I just wanted you to see in real life, like, that there are these three pieces, and that is the magic number for monocots. Oh, one other thing, while I have this plant here, let's talk about a couple other things. So we think about, the roots, the stems, the leaves, and let's look at these leaves. So, and if you didn't know what this was, if you were like, I don't know, is it a monocot? Is it a eudicot? Who knows? Monocots have these long leaves with parallel veins. So if you see, there's like that central vein that's right there. That happens in a lot of leaves. But then instead of having veins branching off from that, they actually all just go up the entire leaves, just kind of next to each other. So not exactly parallel because they would never touch, but parallel-ish, right? All the way down. So that's a really good way to know if a plant is a monocot. It's very easy, even if it's not flowering and you can't see if they're coming in groups of three, you can look at the leaves and see. And this is the giveaway. And they're generally long leaves. Journal activities. Examine, copy, and label the micrograph of the monocot stem in Flora. That's the one that we were looking at earlier. Examine, copy, and label the micrograph of the monocot root in the Ultimate Visual Dictionary and compare. So, roots versus stems. This book's amazing. Let's look and see what it says. So here are the roots. This is page 132 and 133. And this is a cross-section through the root of a buttercup up top. And down here, we have a cross-section through the root of a lily. So there's the lily, which is the monocot, and there's a buttercup up top. So just compare what the structure of the root and versus the structure of the stem are. I think it's really interesting. And here is a cross-section through the root of an orchid. Right there. So also really interesting. Obviously, the cross-section, the ones that are round, it's like here, the root's growing down, and you just cut it like this, and you cut it like that, so it's like a tiny little disc this way, that's why it's round. And then they also have them the other direction. Next step in your journal, gather many different types of monocot leaves to study and compare. So the venation is how the veins branch. Draw or do a rubbing of the venation patterns. Shape. What do the silhouettes look like? Trace the outer edge to see the shape. So the shape is just like if it were just, if you could only, if it was like dark in front of you and then there was a bunch of light coming in behind, like what does that just outer shape of it look like? Or if you put it down into a piece of paper and you just traced it, that outer shape is what we're looking at. Margin is what do the edges look like and feel? Draw a close-up of the margin. So on leaves, there's a bunch of different types, right? So for this one, if you were to just run your hand along the edge, this is the margin right here. What does it feel like? So is it bumpy? If you like have oak leaves, they have lots of things going on them, right? So they're lobed. And if you have azalea leaves, they actually have tiny little hairs all along there. So what is the margin of your monocot? And if you have a bunch of different monocots, is the margin of all of those monocots really similar? and what is it like? And that, again, is something that you can keep adding to as you go along. So write down what you have right now, and then as you find other monocots, you can continue to add to that. So sometimes you'll want to leave like a little bit of extra space in your journal if you know that you're going to keep adding to that section or that thing that you're investigating. All right, so that's it for today, guys. I will see you next time. Thanks so much for joining me today. Bye.